Welcome along to our Trimble TEDDS software demonstration, and in particular we'll be looking at the 2D analysis feature within TEDDS. I like it because it's very simple. There's no bells, no whistles. It only does 2D analysis and it's simple and you can't go wrong. Now obviously you'll be watching this video to help you understand how to use the software to perhaps answer a question or a coursework question set. I may not be looking at the exact question that you have, but for this example, we'll be looking at a small section timber, I think it's 12 mil by 16 mil, spanning a 1 meter distance, and with different loads put on the center point of that member. So first thing to do is if we go on to the software platform itself, and you'll then be presented with an option, either TEDDS or TEDDS for Word. Can I recommend or insist that we only use TEDDS? We'll load the software up. I'll pause the video once it's loaded up and I'll start again. And so here we are, we're back. Now, this is the option that you're given. So if we go in here and just tap the new function, and we'll go a new document, and then this will load up, hopefully load up some options for us. Perfect. Within this menu here, you can see there's many things that the software can do, but for today, we're only going to look at the analysis section, and in particular, the 2D analysis. And we'll go 2D analysis there. And we'll load this up. So that may take a few seconds, but we now have it open. So what we'll do, we do actually have a Word document, a step-by-step guide that you can follow along with as well. It'll be on your middle page for your module, and the document looks a bit like this, Guidance for TEDDS. And we'll follow this through in the video as well, or you can print it out and follow along if you wish. So the first thing I'm going to do is create some nodal points. I'll go 0, 0, then I'll go along 0.25 on the horizontal, and on the vertical 0, then 0.5, then obviously up nothing, and then 0.75, and we'll go up 0, and we'll go along the full length 1 meter, and then we'll go up 0. And then on node number 1, we'll have it fixed on the horizontal and fixed in the vertical. We've got a small triangle appearing. Node number 5, we'll have that fixed in the vertical only, and we'll allow it to have a direction of freedom in the horizontal. So that's perfect. For the materials now, I'm going to press Add, and I'm going to ask for timber Eurocode 5 or timber EC5. Then a menu should come up. I'll give it a few seconds. Here's my menu. I'm going to select this softwood species, C16 Plus. If you're in one of my modules, you'll know that C16 Plus is a bespoke strength class grade for timber specified within the UK. We'll select that as our material, and that brings in density, Young's modulus, the shear modulus, and the thermal coefficient. We'll go into the section, we'll press select, another menu will come up. From there we'll select timber, I think we'll go 12 on the breadth and 16 millimeters on the height. So this is a rather small piece of timber, 12 mil by 16 mil. This is a demonstration for a span over a 1 meter distance with small section timber. Then we'll go elements. we can go 1 to 2, and you'll see an element is created, element number 1, and that spans from node number 1 to node number 2. We'll just finish that off. 2 to 3, 3 to 4, 4 to 5. Perfect. Then we'll go design member. Now you don't need to do this, but I'd highly recommend, because it makes your life a lot easier later on if you create elements or design members like this from the elements. So I'll just press the little 3 dots in the middle for edit, and I'll go start at element 1 and end at element 4. And you'll see that node 1 and node 5 are ticked, saying that they are supported at the nodes. I'm going to give that a name. For just now, I'll call it BOTCORD, bottom chord. That'll do the now. Loading. Right, okay. Self-weight, I'm going to leave self-weight. No, I'm going to take self-weight out as well. I'll not enable that. I'm going to remove permanent load, and I'm going to remove imposed load. And I'm going to add in live LOD 1. And I'm going to add in LI 2. I'm going to do 5 live loads. And one more. Five live loads are created. I'm going to want a nodal load. I'm going to select the middle node. And this is to replicate hanging a weight from a wire on the middle of this piece of timber over a gap. So I'm going to select node number 3. I'll go live load 1, and I'll go in the vertical direction. Let's just find my loads. Yes. In the vertical direction, I'm going to go 0.01. And I'll keep coming down. 0.02. And load number 3, live load number 3, I think I'll go 0.05, and then I think I'll go load 4, 0.075. You can see a pattern now, I'm sure. Live load 5 on the vertical direction, 0.1 of a kilonewton. Right. So you can see what this is going to replicate is if I put a load or a weight in the middle of my cord, my timber, and put a 10 Newton load in the middle, you'll get a deflection. It will deflect vertically. If I take that off, and load number 2, if I put a 20 Newton, measure the deflection, take the load off, and put a weight back on of 50 newtons, measure the deflection, take that off, then put a load on of 75 newtons, measure my deflection, take the load off, then put 100 newtons in the middle of that timber, then measure my deflection, then take it off. So this is what we're replicating, but just using the software. So for load combinations, to make my life a little bit easier, if I just go load combination 1, and I'll go load 2, 3, and then for one more, load combination 5. I am not interested in self-weight. I'm going to go with just. This is a multiplication factor, in a normal design you would go 0.5 or 0.3 0.25 or 35, sorry, depending upon what you're doing, but we're not having any factorization on this. So it's purely multiplying by 1. So you can see on this load case 1, the only load being applied is live load number 1. On load case 2, I'm going to apply only the load from live load 2, and so on down my table. So I now have 5 load combinations for my 5 loads that I have. If I go to my results, I should see some results. We'll go to the nodes. Node number 3 is the middle there. If I just press that just now, we'll see my deflection. So we can see for my first one, which from memory was 10 newtons hung in the middle there, that's going to deflect 6.4 millimeters. My second load case from memory was 20 newtons. My third one, I think, was 50 newtons. My fourth one was 75 newtons. That's 48 millimeters that should deflect, or predicted to deflect. Then the last one, load case 5, which was the load of 100 newtons placed on that member, and that would be predicted to deflect roughly 64 mil. So that's very good. And you can even do an output from that. And you can specify tables and you can specify sketches for various different things. You can turn things on and off as you see fit, or you just select them all. I'll just press summary just now, that's all we'll need. And you can also include, we'll do just the load cases for that. Yes, and if I go all OK, we'll then get the output from this. This will take a bit of time, but whilst that's doing that in the background, what we have in the Word document for this example, we have an explanation that it's all very well having the nice software, but you need to make sure that the data you put in is giving you out the answers that you would expect. And it's quite often what we would do is we would double check an element of the building where we can easily check just the one part of it. So this is a nice example here. There's the equation to calculate the deflection at the middle of that beam, and there's some data there. And I've actually typed this up in Excel for us. So there's P, my point load. We'll do 10 for the first example. 10 for my first example. And we can see that that should give a deflection of roughly 7 millimeters according to this, assuming that I've got my information correct here. And we go up to 20, that's roughly 14, 50, 75, then 100. So it's actually not too bad, it's there or thereabouts. But obviously the analysis software will be more precise. So we've got the answer, yes. So this is the output that we've got from the software. And of course you can tailor that to suit your required output from the software. And of course you can then export this into Microsoft Word for your report based on your coursework that you'll be doing. Now I thought for the more advanced users, I thought if we press recalculate just now, so we'll recalculate this, so we'll go back to the start. Just take a few seconds. I'll have to move it onto my screen. There we are. If I wanted to make this into a truss system rather than just a simple beam, what effect would that have? And what type of truss would I want to do? Well, how about I do a very simple one? So I'll make some more nodes first of all. I'll do 0, and I'll go up to 0.5, then I'll go 0.25, then I'll up 0.25, 0.5, up 0.25, then along. I think you can see the pattern that I'm doing. So I've made another 5 nodes above the first 5 nodes, 250 mil up above them vertically. I'm going to go to Elements, and I'm now going to select node 6 to 7, 7 to 8, 8 to 9, 9 obviously to 10. Then I'm going to go 1 to 6, 2 to 7, 3 to 8, 4 to 9, 9, 5 to 10, and then I think I will go 2 to 6, and then I'll go 3 to 7, and then I could go 3 to 9, and then how about 4 to 10? Okay, we now have a truss supported on node number 1, node number 5. Currently our point load is still node number 3, so we'll leave that there. We're not quite finished yet. If I was to make this into a truss, it would be very difficult for me to make element number 9 connected to number 1, 14 and 5, all with moment connections. So if I'm going to assume that they're pinned connections just now, it's rather easy for me to do that. So I'll go to element number 5, I'll go a release. I'll have a release at the start and at the end. And then I see the little half moon shape on that element to say that that element's being released at that. I'm now going to do that for all of the elements that should have a release on them. That will be, in my case, element 9 all the way up to element 17. So I'll just do that just now. And I'm going to release them both at the start and the end. Be as fast as I can. Excellent. So now we can see all of my elements, other than the bottom chord and the top chord, all have releases attached to them. That's perfect. And what I'll do is I'll go to Design Members. So we've got our bottom chord. Let's make element 5 to 8 as one member. Oh, sorry. Start element 5 and then to element 8. And they'll all be supported at the nodes. Press OK. That just makes things a little bit easier for analyzing at the end. Top chord. Excellent. And now I don't need to touch the loading. The combinations all stay the same. I can now just go to my results. I'll go to deflection. And node number 3. If you remember at node number 3, we had a deflection before, I can't remember what it was. Let's check our spreadsheet, which is 10. Before we had a deflection of roughly almost 7 mil, I think it was 6 mil something. We're now getting almost nothing at all. If we go to, even to the very top one, load case 5, our deflection here is 0.1 of a millimeter. Now that's in a truss type shape. We can have confidence this is correct because we've checked it against, when it was in a much simpler form, against a simple hand calculation. So we know that there's the data in is valid. We've put in into a truss shape, so we know with confidence this is correct. We press output and we'll press OK to that. We should have a nice output from this. So it's finished giving us the output, and we can see some of the results. Now this is a very simple explanation or definition of how you use the software. When you're using the outputs from this, be very careful about not just putting everything into your report. Only put into your report the elements that are actually relevant for your coursework. So this is actually concluding this demonstration. Depending upon which module you're on, there may be further videos demonstrating the use of TEDDS for your module. So on that note, thank you very much.